So this example you gave of this robot video from Princeton, which I'm aware of as well. So then I'm curious, what do you see as being the bigger challenge then, kind of solving general dexterity or actually understanding the desires of humans? And so what I mean by that is, for example, do you think it's more complex to translate any household task, such as clean and tidy the bathroom, into its useful subtasks, which might then be pick up the towel, put the towel on the rack, find the mop the floor, etc., or actually the completion of any one of these subtasks? Kind of what do you think, the decomposition of tasks into meaningful tasks, or actually subtask completion? Which of those do you think is more challenging?
I think the completion of the subtasks is more challenging. I think it's a continuous control problem rather than a discrete problem in a sense. So I think that makes it harder. It's probably got to cover a higher diversity of states. So there might be a very large number of words in the English language, but there's an incredibly great number of different images of the world that you could possibly see. And also I think that a lot of this kind of this idea of decomposing a high level command like tidying my kitchen down to the primitive actions, a lot of that can be learned through sort of large language models and a lot of the work that's going on in NLP today.
One thing I'll just quickly say to that, sorry, is just that actually, I guess I would imagine a case where, for example, it is very much vision dependent as well. So when you tell your robot, clean my bathroom, it might be that actually the towel isn't always on the floor. It might be that, things are always in a slightly different state. So it also needs to query its sensors to kind of actually do that decomposition. It's not just about kind of, translating language or something like this.
Yeah. Yeah. So I suppose I guess you're asking, is it easier for a robot to decide what to do?
Yeah.
Let's say a robot had a set of 100 skills it could do, picking up a towel, putting it on a rail. Those are 2 skills.
Sure.
Is it easier to figure out which of those skills it needs to do at any one time, or is it easier to execute one of those skills?
Yeah.
I still feel like the execution of the skill is the harder bit. I think we're going to get, it's a bit more of a sort of discrete optimization problem, deciding which skill to execute rather than a continuous one. And I think the data that we will get for that is going to be, we're going to be able to generalize. It's just, I think, for example, looking at a room and deciding what needs to be moved where, that just requires a single image, I guess.
I would say not necessarily, but I obviously see that, but I guess you might still need to get a 3D model or something possibly and kind of query on certain measurements still. But
I think that's then the control part, right? If you're reasoning about where does the robot need to move its hand relative to the object, I think that becomes the, how do I execute this skill of, picking up an object?
Yeah, well, I guess the two intersect a bit. I guess, I see what you're saying with it's just a single image, but I would just say it's maybe a bit more than that, because, for example, to see that the towel's on the floor in a room, you won't have to just walk in the room and take a photo. It might be you need to go around the table and see it. So all I mean is it's kind of not necessarily as simple as a single image, but still, obviously, it might just be a single observation of the room, for example. Maybe you first scan the room before, and then you decide. But yeah,
it's hard. It's a hard question to answer because actually we don't really know what this hierarchy is. It could be that it's very likely that we would end up with multiple levels of hierarchy where maybe the high level command is tidy the house, and then that's split into well, okay, I've got to tidy each room, and then you go into the bathroom and then you see a towel on the floor, and then you think, okay, I've got to now put the towel on the rack, and then that requires grasping the towel, and then the grasping the towel requires, you know, then executing that. So there's lots of different levels, and it's difficult to know which ones are continuous control and which ones are discrete control. Difficult to sort of know what the intersection is between each level of the hierarchy, what information flows. Is it just a discrete switch as to which one, or is there also some kind of continuous variable which is passed across the hierarchy, the levels of the hierarchy, to then condition the next level of the hierarchy on the reasoning going on in the previous level? So it's difficult to sort of know what these levels of the hierarchy will actually be. But I think if we were to, you know, if it was just a 2-level hierarchy, and the question is deciding what to do at a task level compared to what to do on a low level motor level, then I think the low level motor level is much more challenging.
Sure. Yeah, that makes sense. But I also agree that it's not so easy to create these boundaries, and in fact, it is just a continuum of hierarchical actions to some extent, and that both are challenging, because even deciding what to do requires reasoning about uncertain observations and scheduling, and also probably redeciding in the process of completing tasks, and so on. So there definitely needs to be some kind of synergy between that lower and higher level components.